Hi there. We just want to finish up a couple of examples for the notes on tree diagrams and counting principles. We did not get to question number 3 underneath the independence event sections. So if you could go ahead and give that one a try, just to practice to make sure we're on the right page. When you come back, it will be complete for you. Okay. So what I've done is I first have my tree diagram listed here, and then I have listed all of the possible outcomes just to make it a little bit easier for when they're coming asking some of the questions. So the spinning 2 even numbers, I said that there was 4 out of 16. 2 odd numbers, again 4 out of 16, which we reduced down to 1/4. Getting next to spinning 1 odd and 1 even. So I went through and I actually just wrote the outcomes out so it'd be easier to figure out which one was 1 odd and 1 even, and I'm getting 1/2. And then spinning an odd sum, you would get an odd sum if you added up 1 odd and 1 even. So you pretty much just keep with the answer of 1/2. All right, so now we are going to the dependent events section. This is number 3. It says that dependent events, the outcome of the first event affects the outcome of the second event. The keywords that you will see are without replacement, different arrangements, and no repetition. So we have talked about dependent events already, about the without replacement. Okay, so the first event, taking, let's say if I was pulling from my popsicle sticks on my desk, if I take a popsicle stick out, and I don't put it back, I've now changed the number of outcomes for the second event. So that is why that is called dependent. The number of outcomes depends on the first. So what they're asking us to do is to draw a tree diagram to represent each situation. Now, on your paper, it's not set up as nicely as this. So just make sure you're numbering your tree diagrams so you understand which question they go with. We're going to look at question 1 first, that says picking 2 letters from the word dog without replacement. So the first choice, I could go to pick a D, O, or a G. On the second choice, if I've now done without replacement, if I picked a D the first time, then I only have an O or G to choose from the second time. If I picked an O the first time, then I only have a D or a G to choose from. And if I pick a G, then I only have a D and an O. So if I list my outcomes, it goes DO, DG, OD, OG, oops, let's try writing the right letter, OG, GD, and GO. So now I'm answering my questions. Your questions for 1 are right here. And so it's asking you, what is the probability of picking an O followed by a G? They're asking for a specific order here, and the only one that fits that is obviously OG, so that's 1 out of our 6 outcomes. And then they're asking about picking an O and a G. This one does not specify order, so you can have one that has an O and a G first, or it can go G and O. So this is 2, 6, which would become 1/3. For the second tree diagram, so again, you're going to want to put a 2 on yours here so you understand which tree diagram goes with which situation. Now you're picking 2 marbles from a bag with 2 green, 1 red, and 1 white. And again, the marbles are not replaced. So to deal with the fact that we have 2 marbles that are green, we do have to take that into account when we draw our tree diagram. And instead of just going, okay, I've got a green, a red, and a white marble, I'm just going to distinguish the difference between the 2 green marbles by putting the little subscript of a 1 and a 2. You don't have to have this, but I think it just helps us keep track of what marbles we're using and which ones we're not. So if I picked a green marble the first time, since there are 2 green marbles in the bag, I would be able to choose another green marble, but it would not be the first one, it would be G2. Then I would have the red one and the white one. If I picked a green marble the first time and it happened to be our G2 marble, I could pick G1, a red one, and a white one. Then if I pick a red marble, I could get G1, G2, for a white marble. And if I picked a white marble, I could get G1, G2, or a red one. So I know that we have 2 green marbles. Be very careful with that. You can't just say, oh, there's green, red, white. You have to take that into account. That changes the number of possibilities, the number of possible combinations. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. Remember, we can count up the last branch of our diagram, and that will tell us how many outcomes there are. So what is the probability of picking 2 green marbles? And it doesn't specify the order. You can only get G1 and G2, or G2 and G1. So that would be 2/12, which equals 1/6. And then what's the probability of picking a red followed by a white? Well, looking at my list, I only have 1 red marble and 1 white marble, so that's only a 1 out of 12 chance of happening. And then picking 2 different colored marbles. 2 different colored marbles, looking at my list, if I had a probability of picking 2 green marbles was 2/12, then getting 2 totally different color marbles would have to be what's left over, 10/12, which will reduce to 5/6. Or you could go through and count up the list where they have 2 different colored marbles. I believe we also didn't do an E real quick. So let me just erase this right here. For E, I want you guys to go ahead and do that one real quick. When we come back, I'll have it ready. You have 3 flavors of ice cream, 2 types of cones, 3 times 2 gives us 6. All right, so I just wanted to make sure again that we were able to complete the notes there. Your homework shouldn't take you that long. I believe it's about 10 questions. If you have any questions, please, I'll say again one more time, please be sure to ask me. Have a great weekend. We'll see you on Monday.